So we have here a metal and a non-metal, and I'm recording this right now, and I'm going to put this on the Haiku site if you need to see it, okay? So, okay, we're starting here with metal versus non-metal. And metals look kind of mad, don't they? And non-metals look kind of happy. Now let's move on to the next slide. And in this one, we're going to start writing stuff down. Metal atoms, they really want to give away their electrons, okay? They want to give away electrons. Because they have a few electrons, these are called valence electrons, and they don't want them anymore. So they're trying to get rid of them. They desperately want to get rid of them. So here again, you've got this metal atom, and he's happy, or I mean, he's sad, he's mad, because he's got this one valence electron. And he wants to get rid of it. He doesn't want it anymore. Okay? Now, on the other hand, go ahead and write that down for metals. They want to give away electrons. That non-metals, they want to gain electrons. Caden, yes?
Are non-metals happier with life than metals?
They're both actually kind of unhappy. Okay, they both... Now, non-metals... This one looks kind of crazy. They already have electrons, and they want more. They're like those people who have a bunch of kids and they just want to keep having more kids. Okay, now they are greedy for electrons.
Wait, is he one of those people? One of those people who are on the side of the freeway just like, please give us.
Here with ionic bonds, an ionic bond is between a metal and a non-metal. So the metal really wants to get rid of its electron, and the non-metal really wants it. So can anyone think of a solution here? What do you think? No, they don't want to cut it in half because the metal doesn't want it. Yeah, so this is what happens is that when you write atom types, you're going to write metal and non-metal. So, for atom types, go ahead and write metal and non-metal.
For ionic?
For ionic.
Who's that?
Now, also in ionic, the electrons...
What's in ionic?
Electrons are donated from metal to non-metal. Yeah. So this is for electrons. From metal to non-metal. I apologize for my hand. When electrons are donated, that metal, when it loses an electron, and that non-metal gains that electron, now the metal is happy. It lost the electron, and it becomes positive. Now, the non-metal has gained the electron, and it has become negative. It's become negative. And because the metal is now positive and the non-metal is negative, they attract. Opposites attract. And opposites attract because remember how we learned about the four forces of the universe? One of those four forces is the electromagnetic force. causes opposites to attract. Okay? Now, moving on to the next part. What are some properties of this? So, what are some properties of ionic bonds? And I'm going to write here properties. So, some properties are that it's a very strong bond. It also forms crystals.
It does?
Yep. Ionic bonds form crystals. They have a very high melting point. Meaning that they're very hard to melt. And then the last thing that you really should know is that in water they conduct electricity. Yep. As far as I know, it's usually in water. I'm not going to say only. I think there's more. So salts are all example. Is a really really good example of a salt.
What about sugar? What about pepper? Sugar.
Salt
Pepper.
Pepper is not ionic. So any salt there's actually a lot of different kinds of salt, but salt is an ionic bond. So salt, as you may know, is called NaCl. Here is your metal, and here is your nonmetal. Okay? So moving on to covalent bonds. So here, covalent. Now what kind of atoms is covalent between? It is between
a non-metal
a nonmetal
and another non-metal.
and another nonmetal.
I'm so smart.
You are smart. So we're going to put nonmetal well, because you have two nonmetals and they're both greedy for electrons, right? If they both want electrons, let's say you have a friend and there's one piece of cake left and you both want it, what do you guys do? You split it or you share it. Electrons are, they are shared, just like you would with a friend. If you both want something and you can easily share it, you will share it. If you have a basketball that you both want to play with, moving on, you've got two nonmetals that share electrons. That is what happens. Now, what are the properties of this bond? Hang on one sec. The properties are the bond is relatively weak. So because the bond is weak, the melting point, what do you think is going on with the melting point? High or low?
Low.
It's a low melting point. Yes.
What does that say? Weak what?
Weak bond. Sorry. Weak bond, low melting point. Okay. Most foods are made with covalent bonds. This forms molecules, so the word molecules is usually a covalent bond. Okay, so when we're talking about these bonds, we're actually talking about compounds too, right? So you can have an ionic compound, you can have a covalent compound. Yes?
Do they conduct or insulate?
That's a good question. They are insulators. They are not good conductors of electricity. And they tend to be, the one other thing about ionic is that they're brittle. They tend to be brittle. That's ionic.
What does the first word say?
So, Examples of covalent, the big example that I like to use is sugar. Okay, if you also gasoline is a covalent molecule.
The one you put in a car.
The one you put in a car. You made an awesome guess with metallic bonds. What do you think metallic bonds are?
Two metal.
Who don't want to give each other their electron?
They throw it at each other.
They push the electron.
Okay, neither of them want it. This is metallic. And this is between a metal and a what?
Metal.
A metal and a metal. And neither of them want it. So it's like hot potato. Okay? Neither of them want it. So if I gave you something that you didn't want, let's say it was like homework. Okay, I've got one homework assignment here that only one person in the class has to do. Here it is. What are you going to do with that?
You just pass it on.
You're going to pass it on and you're going to move it around. So the electrons start to flow around because all the atoms just start moving the electrons around. So, question. So what happens? Well, here's all of your metal atoms, and they are all giving their electrons away. So they goes this way, and then that way, and then that way, and all the electrons just go everywhere, and it's a flow of electrons, and they call this a sea of electrons. Okay? Because they're all trying to play hot potato with those electrons. None of them want it. What was that? So I would write a sea of electrons, or I would say that they all pass their electrons around.
Go everywhere.
They pass electrons around.
So I'm guessing
And then the next part, the properties, they have a bond, but it's called metallic. And the bond is I would not call it strong. Now the bond, the properties make it malleable, which means it can be bent and shaped. Yep, so I would call that moldable, like clay. So metals are moldable, like a paper clip or staple. You notice how when I bend it, it stays like that? Or a piece of foil? That means it's malleable. It's also ductile. That means you can make wires out of it. And it's also an excellent what?
It doesn't show.
It's an excellent conductor.
It doesn't show.
And it is lagging now. But you'll have to take my word for it. It's an excellent conductor. We're almost done, so it's not that big a deal.
Wait.
Now, examples of this. Examples of metallic bonds would be just metals. So if you put copper, if you put iron, if you put gold, if you put mercury, these are all metals, and they're all metallic bonds.
Wait, you can't bend it.